How's it going, guys? All right. So we figured out the length of curves, length of vertical curves, yes?
Yes.
And these lengths of the curve are designed to provide what? Will.
The length of the vertical curve is designed to provide accurate sloping for stopping sight distance.
I don't know what accurate sloping is, but yes, it's to provide adequate stopping sight distance.
Yes.
It's good. I'll take that. I don't know about accurate sloping. Okay. So we have, I would say we know the PVC, the PVT. Now we're going to talk about the elevation of these points. Okay? So typically we know the elevation of PVI, and we would come back along G1 to get to PVC, or we would go forward along G2 to get to PVT. Okay? PVI is not actually on the road, right? It's above the road or below the road.
It could be below. Yeah.
Yeah, if it's a sag curve.
Oh.
Yeah. Right? So, but PVC is the start of the curve and PVT is the end of the curve. So we can get the start of the curve here going in the negative direction. So really it's G1 plus G1 negative L. But we can write it like this. And then we go in the positive L direction, G2. Now if G1 is negative, right, then it just adds it. Right? And if G2 is negative, then it would subtract it. So if you keep this convention, you'll be good with your signs. Yeah? Okay? And that will give us the elevation of the point of curvature and the point of tangent. Okay. Now the curvature of, or not the curvature, but the elevation of any point along the curve is given by this equation, which effectively says we're going to start at PVC, then we're going to go up the G1 tangent until we get to whatever it is that we're looking for, whatever that location is, and then we're going to come down some parabolic function to the actual curve. Now, if this were a sag curve, we would technically be going down, and then we would be coming up. Yeah? But mathematically, it all works out the same. So here's where we start. This is on the tangent, and this gets us down to the curve. Yeah. This is also considered the rate of change of the curve, but that's not really that important. What if this PVC, or what if this point of interest was located on this side of the PVI? We would just continue to go up, all the way up here, and then this parameter would be bigger because it's a square, and we would come down further. It's fine. It doesn't matter. Does that make sense? Oh, we should also talk about the high point and the low point. So, if you were to take the derivative of this, set that derivative equal to 0 and solve for x, you would find the high point or the low point. Effectively where the grade equals 0. So we're going from this grade to this grade on a curve. Where's that curve equals 0? That's our high or low point. So for a crest curve as shown here, the high point will be given by this equation, and likewise a low point would be given by this equation. Yes?
Just because I'm silly, can you just point to where the high point is on this curve?
Ish.
Okay, that's what I thought.
It doesn't have to be under PVI. It's not.
Okay.
PVI is not on the road. It's not on the curve. PVI is above the curve. So the high point would probably be somewhere in here.
Okay, so it's like the max and the min, as you would say in calc. Yes.
Yes. The high point, the max, or the low point, the min.
Got it. Thank you.
Yep. This goes nuts. Great. The crest curve has a PVI at station 1, 2, 3, plus 4, 5 with an elevation of 345.67. Design speed is 55 miles per hour, and G1 and G2 are this and this. Elevation of station 12500 and the elevation of the high point. Okay, this continues from our previous example. There are no markers here. Awesome. Awesome. Will, I was was gonna nominate Will to go steal some, but this will
You're
work.
getting an A. You're getting an A, that's all I'm saying. I would get an
He's gonna get an A,
A. I know.
because he's going to do well on the exams.
That's it.
Okay, do we remember what PVC and PVT were for this?
No, good question. No, there's the Crest one.
It's plus 25. Wait, maybe.
No, it wouldn't be 50.
The PVC was 50 plus 22. Yeah, and we'll get to that.
No, that's the wrong part. Station is the station for PVI is 123, so it should be like 118.10.
Yeah, PVC was 118 plus 10.
And then PVT,
123 plus 40.
123 plus 40. No.
That's what we solved.
Nope.
I think it was 128 plus 80.
128 plus 80 sounds better.
That's kind of a little bit hard to see, just a heads up.
Maybe red.
Yeah, it's just, I don't know.
Well, we don't have many options, so.
Well, you're about to go scavenger us some markers.
Oh, highlighter.
Highlighter's not gonna go.
Oh, okay.
I'm gonna do it. I'm gonna take the old stopping references.
As long as it's not a permanent
Run
marker.
off this.
No.
Wait.
So you got markers.
Looks like the class saved us.
I start bringing markers. That's what I do. I'm not a paper class. Jeff is so- I'm confused, it's not because I'm silly.
Okay, what do we do?
I just don't know where we got those points.
This is the same exact Crest
Oh, from
problem
last time.
from last time.
Okay, okay.
You're right, that was.
Thank you.
What?
What?
Okay. Find the elevation of station 12500 and the elevation of the high point. Okay, let's find y PVC equals y PVI minus G1 L over 2. Yeah? Equals 345.67 minus 0.0395 times 1070 over 2. And then likewise, y PVT will equal y PVI plus G2 L over 2 equals 345.67 plus negative 0.0425 1070 over 2. What is YPVC? While we're calculating this, I'll tell you a little anecdote. As I was just studying for my PE exam, there was a vertical curve question. And I had thought I got the problem wrong, which I'm as shocked as you are. And then looking at it, I realized that they calculated the stopping sight distance incorrectly. They didn't take into account any of the grades of the vertical curve and therefore got the wrong stopping sight distance, and then calculated the length of the curve wrong.
The study book did that?
Yes.
Did you email them?
I'm about to. This is why PhDs shouldn't be allowed to, shouldn't be required to take the PhD exam. PhD, it's stupid. I'm gonna sit there, it's gonna bother me all day. Like, why would they ignore the grade? When it's clearly, there's a downslope to this thing. All right. With that fun anecdote, we should have some answers, yeah? Which here?
For the first one, I have 122 plus 94. Unless I.
Nope, we're doing elevations here.
Oh, okay.
324.5. What are we rounding to?
2 places.
4.
And that's for PVC?
Yes.
All right, what about PVT?
368.41.
Okay. So if we were to sketch this out a little bit, we have PVI at 345.67, PVC at 324.54, and PVT at 368.41. Does that make sense?
No.
PVI is above the road.
But,
PVT has to be underneath PVI, or at least equal to it.
so what went wrong?
You
PVT is incorrect.
forgot this negative?
Is this a plus negative?
Yes.
Why would you do that?
Because it's a negative grade. If you just keep all of the equations, for the most part, take care of grade, take care of sign, and take care of conversion factors.
Okay, now it makes sense.
What do you got?
322.93.
22.9 feet. 322.9. Oh. More brain stuff.
And this is from the datum line, correct? Right? That's what the Y is.
Sorry, what?
Just because we had the heights before, since it's Y PVI or something like that, it's just from the datum line specifically?
Yeah. From sea level or whatever we're measuring
Okay.
from, it doesn't matter. We're just calculating the relative difference, right? And then adding in whatever benchmark we have.
This may be a dumb question, but in the first equation, we're subtracting, and the second one, we're adding. Why was that?
Because this is the positive x direction.
Okay.
We're going from PVI into the negative
Oh, I
direction
see.
to go back to get PVC, but we're going in the positive direction to get PVT.
Gotcha. All right.
Yep. Okay, sound good? Okay, next we have to calculate, we're gonna calculate the elevation to station 12500. So we have to calculate the x for 12500. 125 plus 00 equals the station of x minus the station for PVC equals 125 plus 00 minus 118 plus 10 equals 690 feet? Yes. Right? Then we can use our equation y of x equals y of PVC plus G1 X plus G2 minus G1 X squared over 2L. Right? Equals 324.54 plus 0.0395 times x of 690 plus negative 0.0425 minus 0.0395, 690 squared divided by 2 times 1070. Y of 125 plus 0, therefore equals done. Do most engineering classes follow this kind of talk a little bit example, talk a little bit example kind of thing I'm doing? Pretty standard? All right. Will, how's it going?
Wonderful. How are you?
Super, thanks for asking.
I got 333.55.
Okay, we're saying that the high point is somewhere over here. No, that's not high point, sorry. We're not at the high point yet.
It's the station.
Yeah, it's the station for 125. So 333 is somewhere underneath here, but above here and here. So yeah, good. Okay, let's do more brain stuff. You know, this guy who just taught this had a black marker.
He took it with him.
That's fine. I think it can have this on camera. I don't care. He must have taken it with him.
I want my marker back too.
Took it with him. Okay. X for the high or low point equals G1 L divided by G2 minus G1. Therefore, we have 0.0395 times 1070 divided by negative G.
Isn't it G1 minus G2?
It's G1 minus G2, yeah. 0.0395 minus negative 0.0425. Because we have a grade in the numerator and a grade in the denominator, we could actually just keep them in percentages, but I don't want to inflate things.
Appreciate it. Thank you.
Yep. What do we got?
515.4.
515.
0.43.
Okay. And then, of course, the y to the low equals the y of PVC plus G1 x low. Sorry, I'm talking about a high point. G1 x high plus G2 minus G1 x high squared over 2L. So if you still have it in your calculator, you can scroll up, re-enter, go back and change the x. opposed to entering it in all over again.
I wasn't that smart to. I wasn't smart enough to just go back and do it.
334.7.
334.7.
2.
Okay, where would that fall on here? That would fall somewhere around here. We're saying that this is X high is at 334.72, which is under this and above both of these, and is still above our station 125. Probably the right answer.
Sounds good.
All right, let's try another one that is a sag curve, just for practicing. See, I think the meeting twice a week for an hour and a half or whatever it is, an hour and 15 minutes, is way more efficient than meeting 3 times. I mean, by the time we get in here and I'm done being me, start actually professing, we've already wasted like 15 minutes. So. Okay? All right, what is the station for PVC from last class?
50 plus 22.
50 plus 22, and PVT?
58 plus 42.
Okay. Okay, and that means that L is
820.
yeah. L is 820. Okay, good. Okay, and oh, YPVI should be given here as 7654. 7654. And Y. Oh, PVI is 5432. 54 plus 2. Good. Okay, find the station for 5600 and the elevation of the low point. So, Y PVC equals Y PVI minus G1 L over 2 equals 7654 minus negative 0.035 times 820 over 2. Y PVC equals nothing.
plus 46.
Mm,
Might check.
What'd you get?
Hold on. Let me double check.
I got 90.89.
90.89. Going 4, we're adding about 12 feet. So 82. 90 might be right. What'd you get? 90 what?
0.89.
90.89 feet. We'll go with that for now.
Yeah, 90.89.
Okay. And then YPVT equals Y PVI plus G2 L over 2 equals 76.54 plus 0.0615 times 820 over 2. Y T equals something.
101.76.
101.76 feet. Yep. Like 6 times. No, 4 times 6 is 24. Yes, yes. All right, I gotta make sure all this stuff makes kind of sense as we go along. Okay, so if this is at 76 and this is at 90 something, and this is at 106 something. Yeah. So as we're going through this, I'm going in my head, okay, I'm moving over 420 feet at 3% or 3.5%, so I should get 3.5 times 4. And I'm going to add that to my PVI. And then I'm going, all right, we're moving at 6% times 400 feet, 24 feet. I'm going to add that to 76, and I should get something around 100. Just trying to verify this in my head, and drawing the sketch out is going to help. All right. Good. Okay, so the X to station 5600 equals 5, 6 plus 0, 0 minus my PVC, which is 5, 0 plus 2, 2. My net X therefore equals 478 feet.
Hmm?
1 plus 4 is, no. 578 feet. That's 5,
Yep.
yeah, 578 feet. Okay. Y of 5, 6 plus 0, 0 equals Y PVC plus G1 578 plus G2 minus G1. I don't know why I'm doing this kind of hybrid weird thing. G1 X plus G2 minus G1 x squared divided by 2L equals YBC 90.89 plus negative 0.035 times 578 plus 0.0615 minus negative 0.035 times 578 squared divided by 2 times 840.
$820.
820, that was a good catch, solid. So as I'm studying for the PE, I realized there's like way too much stuff to actually like know. So I'm just gonna take all the stuff that I already know and like do those real quick, and then just use logical deduction to do the other answers. I mean, it's not like hard stuff. It's like the area of parking lots.
On the PE exam?
Yeah, it's like stupid stuff. Like, all right, if I sat down and actually thought about it, I can calculate. You need, parking space needs to be this wide, this long, and so much needs to be reserved for stormwater, and I can calculate that.
Of course.
Yeah. So it's just gonna take me a little while to like sit there and do it. And you only have 6 minutes per question. So I'll just go through all of the all the stuff that I really know in depth, like this stuff, right? Get that out of the way with like 1 minute per question. And then just spend the rest of my time agonizing over the questions I don't know the answer to. That's my plan. I'll let you know how it goes.
We'll find out.
When do you take it?
October 22nd, but I won't know the results until probably next semester. Like 8 weeks.
Is it online, right?
No. Oh, the FE is online, the PE is paper and pen, 8 hours.
90.32.
What'd you get?
90.32.
Okay, and then x of my low point equals G1L over G1 minus G2 equals negative 0.035 times 820 divided by negative 0.035 minus 0.0615. I think it was last year or maybe the year before, I don't remember. I put one of the grades as 0 for the exam, on the exam. Like, G1 is negative 3% and G2 is 0.
Disaster.
A complete disaster. Just a complete unmitigated disaster. It did not work out well. So then I gave them like the same exact question on the final to like redeem themselves. Also disaster. No redemption was had.
Would you just plug 0 in for everything else?
Yes, you would just go through the exact same process that you went through, and one of the grades is 0. So it's like a curve that looks like this.
Not a curve,
Here
it's just like.
and here.
So what you're saying is the grades match the grades for that?
Yeah, so PVT was the high point, right?
Sure.
And PVC was the low point.
I can see how people get confused with that.
It's, you could blindly go through
Yeah,
it
you
and
just
just
do.
plug the numbers in where they're supposed to go and you would get the right answer.
I feel like if you just did the math and were like hoping the math was right, but if you like tried to like.
Or you could
deduce
sketch it out
yeah.
and realize that, yes, you're also right.
Like
Wow.
if I didn't know anything and I was just doing the math, I'd be like, oh no, what did I do wrong?
Yeah, and then you panic and throw up on the paper.
You had a student though?
What's that?
You had a student though?
No. I had an awkward breather once. You would just,
It's mouth breathing, it happens.
yeah, but it was like super distracting.
Yeah,
So I got one student sitting behind me going, oh my God, I can't make him not breathe.
I mean, you could.
You're right.
You get a lot of emails about it. Breathing, stop breathing.
Like, what am I gonna do? All right, what do we got?
297.41.
Equals 297.41. Sounds good. Okay, and then y for the low point equals 90.89 plus negative 0.035 times 297.41 plus 0.0615 minus negative 0.035 297. I know no one can see this, but you should know what we're doing because it's identical to everything else that we just did. And that gives you some answer.
85.69.
We're saying that this is 85.69. It's under that, and it's under that, and it's above that. We're good. Okay? However, if one of these grades were 0, it would be a little different now. There you go. Okay. All right, that's the end of that. We killed it. We could do pass-through point curves. I generally reserve that for the graduate class, so we'll just put a pin in it right here. How about that? Yeah, we can stop.